Hi everyone. Now, from what you have learned in kinetic particle theory, we all know that particles are in constant random motion. So particles are always moving, and in the case of a solid, particles are vibrating about a fixed position. If we increase temperature, it has been observed that the particles will start to vibrate more vigorously, and therefore the average random kinetic energy of all the particles will therefore increase. Similarly, when we decrease temperature, the average random Ke of all the particles will decrease. That is the reason why in point 3 of the learning objectives, you see that temperature is a measure of the average random kinetic energy of all the particles in the system. Now, there is a need to define what is this random kinetic energy. Random as opposed to, say, translational kinetic energy. Random kinetic energy of the particles, as the name suggests, is due to particles moving randomly. Translational kinetic energy of the particles arises when the whole system of molecules or particles moves in a certain direction. For example, you can be holding a bottle of water, and the water molecules are moving randomly. So they possess random kinetic energy, which is linked to the temperature of the water. Now, if you bring this water bottle up onto a plane that is moving very, very fast, the water molecules now possess additional translational Ke, because the water molecules as a whole system is moving very, very fast. The temperature of the water, even when you bring the water up onto a fast-moving plane, doesn't change, despite having additional translational Ke, because temperature is only affected by the average random kinetic energy of the particles, which didn't change. Now, we have established that the average random kinetic energy of all the particles is related to the temperature of a system. Now, what if we take all these random kinetic energy of all the particles and we sum it up together? We add up all the random Ke of all the particles. We will get the thermal energy of the system. So, in short, you have to remember that the average random Ke of all the particles is related to the temperature, and the sum of all the random Kes of all the particles will give you the thermal energy of a system. Now, let's move on to our last learning objective for this video. You know that there are only two main forms of energy in the universe: energy of motion, which is the kinetic energy, and also energy of position, which is commonly known as the potential energy. So if we sum up all the kinetic energy of the system and the potential energy of the system, we should get the total energy of the system. We use the term internal energy to represent the total energy of the system. Therefore, the internal energy of a system is the sum of all the kinetic energy of the system, which is equivalent to the thermal energy as what we have established in learning objective 1, with the total potential energy of the system. And hence, you will see in learning objective 2 the definition of what is internal energy. Now, if you are still with me, I will share with you one last point in this video. The first law of thermodynamics. This is actually optional, but I felt that this can allow you to link what you have learned previously on work done to what you will learn later on in this chapter. So, you now know what is internal energy, the total energy of a system. The symbol to use to represent internal energy is a U. Now, any changes in the internal energy of a system must be due to work done on a system, which is what we have learned previously, where the effect of a force on a system can either increase the energy of the system or decrease the energy of the system. Now, the second way to change the total energy or the internal energy of the system is through heats given to a system. So, to end off this video, note the following key points. If I take the average of all the random KEs of the particles in a system, this is representative of the temperature of a system. If, however, I take the sum of all the random KEs, then I will get the thermal energy of the system. If I take all the random KEs and I add it to all the potential energy, I will get essentially the total energy of the system, which is something called internal energy. And the optional point about the first law of thermodynamics, note how to change the internal energy. Basically, there are two ways of doing so. One is through work done on the system. The other one is through heat given to the system.